Okay, welcome back to Service Math, your Add Math teacher. Now, we are still on differentiation as we have started previously. We are continuing with the chain rule. So today I'm going to teach you how to use the chain rule in our differentiation. Now, let's get to the example on the board. Now, when we take the chain rule, it has a formula which says that dy over dx equals to dy over du times du over dx. Now, when we take a look of this example 1 over here, we can see that a function which is y equal to into bracket 3x plus 1 or exponent 7. Now, let's explain what this means to the formula. When we pick the y function, it's equal to 3x plus 1 raised to the power 7. The 3x plus 1 is the u over there. So the u has exponent 7 over here. Then when we pick at the replace of the u, we have the 3x plus 1 over there. So now let's get to the working and see how it is done. So we say that let y equal to 3x plus 1, which is our u, which will be u exponent 7. Then we are going to differentiate this function, which will be dy over du equal to 7u exponent 6. We have taken 1 from the exponent, so it will be what? 6. Now, the next thing is that you have to get what is here, which is what? U. But the u is what is being replaced at the u is what? 3x plus 1. So our u will be equal to what? 3x plus 1. Then we are going to differentiate the u to the respect of what? X. So our du over dx equal to 3. Now what we are going to do here is that you now substitute what we have just differentiated into the chain rule, which we are going to get dy over dx equal to our dy over du is what? 7u exponent 6. Then times our du over dx is what? 3. Now we are going to multiply 7 by 3. So 7 by 3 will give us what? 21. So now we'll be getting 21u exponent 6. Then we know we can see our u here. So we are going to replace the u with 3x plus 1 over here. So we have 21 into bracket 3x plus 1 or exponent 6. So this is our dy over dx as we have simplified. Now let's get to number example 2. This is also the same chain rule, but you can see that over here we have been given in a fraction form. So the best way to rewrite it, you have to rewrite this in a linear form. So let's rewrite it in our linear form. It's going to be y equal to 1 minus 5x exponent minus 2. We can see that we are able to apply the rule of indices over there. So now, as we have learned in the example 1, this is our y function, and then this is our u. But at the replace of u, we have 1 minus 5x. And then the exponent of the u is this. So we start by let y equal to the u function with each exponent 2. Then we are going to differentiate y to the respect of u. So we get dy over du equal to minus 2 u minus 1 minus 3. Then the next thing is what? This is our u, but what is at the replace of u? 1 minus 5x. So our u is equal to 1 minus 5x. Now we are going to differentiate this to the respect of x. So our du over dx equal to minus 5. Now when you are done, just substitute all these back into the differentiation rule, which says that our dy over dx equal to dy over du times du over dx. So when we substitute it into our formula, we will be getting our minus 2 u exponent minus 3 times minus 5. So our dy over dx equal to positive 10 into bracket. We know our u. Our u is giving us 1 minus 5x. So you substitute it over there. So we're having 1 minus 5x exponent minus 3. But we have to rewrite it. So we should be dy over dx equal to 10 all over 1 minus 5x exponent 3. So this is what it means by differentiation by the chain rule. So this is our final answer. Now let's head to example 3. The same approach must be done here. We know let y equal to the u, which is the u raised to the power 2. So we differentiate y with respect of u. We will get dy over du equal to 2 raised to the power u. Now the next thing is we have to pick our u over here. So our u equal to 2x squared minus 5x. Now we have to differentiate this to respect to x. So we have du over dx equal to 4x minus 5. Now since we are done with our differentiation, we have to just go and put it into the chain rule as we have studied from example 1, 2. So our chain rule equal to dy over du times du over dx. So we substitute what we have differentiated over here. So our dy over du, we have 2u times 2x squared minus 5 minus 5. So this will multiply this. So we can have 4x squared minus 10 into bracket u. So we know our u. So we only substitute our u back. So we have dy over dx equal to 4x squared minus 10 into bracket 2x squared minus 5x. This is differentiation respect to the chain rule. Thank you for your view. Just subscribe and like and follow Sedisma channel. Thank you very much.